So applying the power rule then, we just want to apply the power to the coefficient and reduce the power by 1. So in this case here, we want the change in this function over the change in x or the slope function. So the y prime is going to be, so I'm going to bring that power down, becomes 9x squared, okay, plus the slope on 3x. This is a linear function, slope is 3, plus the slope on a constant value is always going to be 0. Okay, those always differentiate to 0. So there's my derivative. I don't really need to write the plus 0 there, but I'm just doing it for emphasis for now. So for the next one here, again, we can just do the power rule. Sometimes people find it easier to write the power instead of having the root there. Write it actually as a power. And at the beginning, sometimes it's easier to apply the power rule when you see the power distinctly like this. So we apply the power rule here. So y prime becomes 8x cubed minus 1/2 times 3 is going to give me 3 over 2. And the power becomes negative 1/2. The slope on 4x is 4 plus 0. Okay, and then I can just kind of clean that up a little bit. I can write that power again as a root function. So 8x cubed minus 3 over 2, so the negative power brings it to the denominator, plus 4. So there's my derivative. So same thing here, if we can isolate the power on that expression, it's maybe a little bit easier. So when I write it as d over dx, this one's already has the power on it. And I'm going to apply the power here. So this becomes 1 over 8. And this becomes x to the negative 1/2 to the power 3. So negative 3 over 2. Okay, so then applying the power rule here, I get the derivative function is negative 4 over 3. I'm going to reduce the power by 1. So negative 7 over 3. I'm going to multiply these powers, so this power comes to the coefficient, so it becomes 3 over 16. The negative negative becomes plus, and then x becomes negative 5 over 2. Okay, so I can kind of leave it like that. If we want, we can put it into its rational form. So this is negative 4 over 3. This is the third root of x to the power 7. This is going to be plus 3 over 16. And this is going to be the square root of x to the power 5. Okay, so there it is. For this one here, we're applying this to slope. So we still want to find slope equations. Okay, in fact, we want the tangent slope, the tangent line equation. So for the tangent line, I need a coordinate, which I've been given, and I need the slope. So if I want to write the equation of tangent line, the first thing I'm going to do is I'm going to differentiate. So I have an equation that allows me to calculate slope. So this is my general formula to calculate slope. Okay, so there's my derivative. I applied the power rule, so 3 times 3, reduce the power by 1. The slope on negative 2x is negative 2. I want to know the slope value at x equals 2. Remember, the input is x, the output is now my slope. So I end up with 2 squared times 9 is 36, minus 2 is 34. So the equation of this tangent line works out to be y equals slope of 34. The coordinate is at 2 and 20. So there's the equation of a tangent line in the point slope form. And the point slope form is generally going to be the easiest way to write the tangent line equation. For this problem here, it asks for the equation of the normal line at x equals 1. Well, for a normal line, well, any line, I need a point and a slope. Okay, so the first thing I'm going to do is actually I'm not sure what happened there. First thing I'm going to do is I'm going to find the y coordinate of this graph. So when I plug in x equals 1, I get 5 times 1 cubed minus 4. That's 1. I need the slope now because I need the equation of the normal line. So normal line, normal means perpendicular slope. Okay, so I want the negative reciprocal slope of the tangent. So I'm going to write perpendicular slope of tangent line. Okay, so I'm going to find the slope of my tangent line. Well, I need to find my derivative. So I'm going to use the power rule to find my derivative. And again, we don't use the Newton quotient unless we're asked to. So now I'm going to apply the power rule. So it's 5 times 3. Reduce the power by 1. The derivative of 4 is going to be 0. So I want to find the slope value at x equals 1. And I'm going to get a slope value of 15. Well, converting that to tangent, that's the tangent slope. So I want the perpendicular slope. So if I want the perpendicular slope, I have to convert that into negative reciprocal. And there's my perpendicular slope. So I have all the pieces I need. I've got my x and y equation. So I'm going to write this as y equals, my slope is going to be the perpendicular slope that I worked out. And then I'm going to plug this into my point slope equation. So there it is. There is the equation of the normal line of this graph. Okay, and I'm going to show you what this looks like on Desmos in the next video.